The times, they are changing, as Bob Dylan once texted, and they're changing fast, lightning fast in generative AI. Why is that actually the case? What implications will that have, and where will that take us? Generative AI is a mighty enabling technology, an enabler of our future technological progress. And the reason why it's been adopted so quickly is that you can think of it as actually a booster for things that you've already been doing with a computer, making that just much more effective. So it's essentially an afterburner for the things that you have been doing in computing, and that's why adaptation actually worked so quickly. Computers, personal computers in particular, as well as AI then running on them, are super powerful devices because they're so enormously versatile. They can process pretty much arbitrary input and then create almost arbitrary output. And generative AI is making this process even more powerful. But if you have this general purpose system that can input pretty much anything and then create corresponding arbitrary sort of outputs in arbitrary domains, how do you actually make it do what you want? The answer to that for decades has been programming. As a professor for computer science, that's evidently something that I can only sort of tell the next generation is important to learn. But at the same time, it comes with its very own challenges. We know that programming requires skilled engineers, software engineers, programmers. It is typically a very costly process, and that you all know and have seen, it's actually creating and prone to create bugs, problems, where the program is not working the way that you actually want it to work. Now, generative AI, I believe, is profoundly changing the way that we do this, not create blue screens, but the actual applications that we had in mind. Say you're a designer. Rather than designing it yourself, you can now tell a computer, in that case the generative AI, for instance, Stable Diffusion that my team here had developed in Munich, what you actually want to see. Or you're an architect, you describe what you want to see. And then the computer turns that into an image. Let's say you want to design a website, a graphical user interface. You merely sketch it, very crappy sketch here, and then the computer turns that into the code, which then generates actually what you wanted. Or you take your program and ask the computer to correct it, to improve it afterwards. Now, we know that the systems are not perfect in what they're doing here. They have, however, in a lot of tasks already reached on par performance with their human equivalents. Here or there even superseded it. And even where they are not sort of outperforming our human abilities, they are, at least as you see in the bottom case here, a welcome support infrastructure. So it's not like fully automatic, but they're still creating a lot of value. So what you're seeing on the left-hand side, I would advocate, is a new way to computing. Rather than programming the machine what to do, you're describing what you want to have. And considering such a powerful approach, the first question that we should ask ourselves is, what issues does this approach have? What are potentially mitigation strategies? And how will such an AI support us in the future? For that, I would say that we're looking at an entirely new age of designing applications with computers. A generative AI prompt-driven approach, if you so want, to application design. And to understand that better, I want to contrast that against the classical approaches that you might have seen. First off, there's software engineering. You sit down, analyze the problem, then you devise a solution, think of it. You eventually have to implement it, and then you test it, and you realize it did not work. You need to go back, redesign your solution, implement that until you get what you want. That requires a lot of human skill and a lot of human effort in all of these orange boxes here, which are labor intensive and require human skills. Machine learning, decade ago, 2 decades ago, has changed this paradigm. You still have to analyze the problem, but now rather than writing down the solution, you develop a learning algorithm that then learns to figure out a solution for you, implements it, and then you train the approach. You have to acquire training data, you train it, evaluate it. If you feel that you're not succeeding, you're changing the learning algorithm, not the solution itself. And now comes generative AI, this prompt-based approach to developing novel applications. And this is changing things. Rather than developing the solution itself, you're describing the problem that you want to solve. And then ask the generative AI to devise a solution for you. So you're not developing the solution or learning algorithm for it, but have the generative AI do so for you. You evaluate the answers, maybe you go back, and you sort of come up with a new description. Now, where's here the skill? Here's the skill actually in coming up with creative, interesting questions that you want to ask. It's all about being creative and finding the right questions that you want to ask, and then have the algorithm provide you with answers, or at least help you. I'm not advocating for a fully automatic approach, but help you in devising an answer. And there are two important sort of aspects here of generative AI. First, I see it as a very powerful general purpose approach. And secondly, and that's what I want to here outline, I see a direction going in the direction of zero to almost no programming involved in actually devising novel solutions. And that has implications. Rather than requiring huge software teams or lots and lots of data, we could now see rapid development of novel applications tailored to a particular customer's need. And with that, I see novel opportunities. Novel opportunities, particularly also for the European continent. I dare to ask kind of this Star Wars question here, like, is there a new hope? In that case, a new hope for technology, IT technology in Europe. What I mean with that is that so far developing such a software stack required all the capital in the world that you had, all this large sort of scale teams that we have with all the skills that only the big tech companies actually had available. What you now need is what we essentially have here. You have these small or medium-sized companies who are world market leaders in their field, have direct contact to the customers in a particular field, and with that access to proprietary data. You might not need like all the Facebook data in the world. You need this very proprietary data that you have there, which sets you apart from what anybody else or the big tech companies for that matter can do. And because you now can much more effectively, closed in a smaller loop, generate novel applications and tailor them to the particular task at hand, you can do so without having all the engineers in the world that only a big tech company had. And with that, I think that there is actually, contrary to what's typically sort of portrayed here, a novel hope for AI in Europe. Second direction that I see here in the future is utilizing the large amounts of unstructured data that there are out. Deep learning has been standing on the shoulders of big data which had been carefully curated, carefully annotated. But guess what? There's much more data out there, which is like audio, text, video data, which is just messy, super heterogeneous. Nobody sort of tagged that, analyzed that, and now utilizing that for training will create much more powerful algorithms, and then analyzing this data, sifting through it, having an AI actually sift through this unstructured data actually can bring up very sort of precious content that we didn't have beforehand. The third is, I see a trajectory to ever more complex tasks. As a field, machine learning, we've over these years, the last decade, developing algorithms which were focused on individual class, let's say human faces, because they're very important. And as you can see here, quality has tremendously increased. The size of data that we're analyzing has tremendously increased. But this was just limited, a single category, as important as it is. Last year saw the breakthrough with algorithms such as Stable Diffusion and many others. Now it's possible to essentially handle arbitrary images and generate arbitrary visual content. But this is not the end point. We now see a takeoff to much more complicated domains, 3D or video synthesis for that matter, which are evidently much, much more complicated. But there is a catch to that. What we've seen so far is making tasks ever more complex by the year or the month. But the approach to doing so was mostly by taking this approach and making it larger, scaling it up, more parameters. And that essentially meant that it also requires more compute. There's a problem to that. You might say you've heard of Moore's law and so on, but there are limitations to that. Limitations in the sense that the available compute does not scale as massively as the models that we need to keep up with these increasing problem sizes. That means not just an enormous cost in terms of money, but also carbon footprint and the like, and not just for your small entrepreneur there, but even for big tech companies. That as implication, and that was our motivation for actually developing Stable Diffusion, means that fewer and fewer players will in the future have the necessary resources to actually develop novel algorithms in that field. And that means we have fewer key players, less diversity, less creativity in that case. And we would potentially run into a monopoly of a technology that I see critical for society and for our future sort of development there, letting alone like other questions such as data privacy. So our goal was to, and I believe this is also an important goal for the future, to democratize the development of generative AI by essentially rendering smaller algorithms that you can run on your hardware that you have available and be, with that, much more effective. Now you might say, well, isn't there something like exponential growth that we're seeing? And I agree, it's been there. That's been the workhorse and powering everything that we've seen so far. But we see actually limits to growth. I'm taking here this theme of the Club of Rome to a certain extent. Now, I don't want to draw here a pessimistic point of view. I just want to sort of divide two things from another, which I believe are very important to understand where we will be going in the future. This limitation point, this threshold where individual entities are out of game differs, whether you're an individual consumer, whether you're a university lab, or whether you're the biggest tech company out there in the world. But even if you are, you see performance now starting to decline because even these biggest tech companies don't have infinite resources available. And so we see examples such as GPT-4 these days, because compute, even for a company as big as OpenAI, is not just for free. We see here deteriorations in performance. The model size, and that's here the key aspect, if you look at the statistics that I don't have time to point out, the model sizes actually keep growing almost an order of magnitude faster than the compute that we are provided with by companies such as NVIDIA and the like. There are bounds on the effectiveness of just scaling up your models in terms of limitations in data, the compute that we have, and that means that we will see and have already seen a tremendous increase in cost. I, however, think that generative AI will also in the future become ever more beneficial for more and more applications that are out there, but not by merely taking what we already have and just making this larger. Look for an analogy, it's this one here. The computers that we're having these days are not the electron tubes that we had more than half a century ago and them just running on steroids. There was development, critical development happening in between that led to all the breakthroughs that we needed to now turn compute power into something that you can carry around in your pockets. And that's what we also will need in the future. We are not done there yet. We're more like on the level of the electron tube than the final computer that you see here on your right-hand side. So that led us to actually wanting to democratize generative AI, for instance, in Stable Diffusion. That's what I see as one of directions in the future. That meant we want the algorithms to be powerful, but at the same time accessible. Accessible, not just releasing them open source, but much more importantly, making sure that whatever we're developing here runs on consumer hardware. Consumer hardware that you can buy for $300. These days, it's even running on your mobile phone. The challenge, however, is if you want to build a visual synthesis system like Stable Diffusion, and understand about everything that's there in the visual world, you need to train it on lots of data. Billions of images, hundreds of terabytes of data. How you get this volume into just a mere 10 gigabytes that you have in your consumer GPU or in your mobile phone, just 2 gigabytes. How can you essentially get the entire internet, abstract away what you don't want and fit that into your pocket that you can take it with you to learn abstraction of reality? That is the challenge that we've addressed in Stable Diffusion that made this sort of then streamlined to all the millions that are now using it. The second direction, and this is now a more recent approach that we've been advocating, recently published, is you take your favorite generative AI here, for instance, Stable Diffusion, which you tell what you actually want to render. And then in addition to just doing it this way, you utilize a database or even the internet. And then with your prompt, have it look up site information from this database, which is hopefully helpful. Yeah? Like these patches here. And as you can see, now the generative model can become much smaller because this database provides you with a lot of information that so far we've been saving in the precious parameters of our AI. Now utilizing, knowing, like we human beings do, yeah, you're not memorizing the entire world, you just know where something is standing. And that's exactly what we're doing here, and that helps us make these models also smaller. And then there are a lot of additional strategies, such as taking large models, distilling them into something smaller, or mixture of experts approaches, like they're also now utilized by GPT-4. All of this going in a direction where we actually downscale models. Now what's the conclusion? I think the path towards a much more powerful AI is not merely taking the things that we already have, GPT-4, Stable Diffusion, or whatever else it is, and just scaling them up. It's not a mere engineering task to get us in the future, as important as that is. We need new approaches which actually make things then also more efficient so that you can actually run them. I still see a tremendous future demand for compute. And I guess we need to grasp and comprehend that compute in that case will become the commodity that is as critical as what we had with electricity, water, and so on for the future development of this particular technology, also here in our soil. That is important because we are going for ever more complicated tasks requiring ever more data. And lastly here, generative AI now lowers the entry bound for actually addressing novel tasks, for doing software engineering, so that you don't need these large teams anymore, that you don't need infinite amounts of capital. And with that, I guess there is a trajectory to a novel hope or a new hope for Europe also in this particular field, where so far it's been mostly, at least as it's portrayed, big software companies. What do we need? And with this I want to end. We need resource independence. Without that, it wouldn't even make sense to think about like legislation and all these things if we have dependence on foreign sort of compute there as the most precious commodity. Second, it's not just engineering. We need further sort of development of more efficient models to just make sure that this AI will in the future also be democratized and be able to sort of spread out there, and we are not getting entirely dependent from the outside. And last, I see very quick and faster development cycles of applications generated using the power of generative AI. But this requires also, on the flip side, a flexible, very dynamic environment with the legislation, everything, the bureaucracy, at least being tied down to the barely necessary that you have here to support these quick development cycles, so that we here in Europe are back in the game again. Thank you for your attention.
Well, that was exciting. Thank you. So a couple of questions to follow on your talk. I think together with the attention is all you need paper from Google, your work is probably amongst the most cited and probably some of the most exciting that has come out of AI in the past couple of years. When you started doing your research on diffusion models, did you anticipate that mainstream people are going to be so excited about your work?
I must tell you that for a long time I've been in the field of computer vision. And at some time you thought, like, when will we be able to solve problems? When will this technology will ever come to the stage that it can solve something as complicated as understanding images? And after some time you see these baby steps that we've been taking. And my comparison is that I always try to push what's possible. And at best, the algorithms followed in this direction. And the moment that we were actually developing these generative AI, Stable Diffusion and its predecessors, it started that you didn't just push, but it started to roll. It started to learn things that for the first time we didn't hardwire into the system, that we did not conceive of. Best example, the predecessor paper of Stable Diffusion, the VQ Gun paper, it started to learn reflections of mountains in a lake, shadows that had been cast, without us ever providing this information, just presenting a data and then having in a self-supervised manner learning that. And that this, the moment that I saw this, I got this feeling like, whoa, this is big, this will have tremendous implications. If algorithms can learn things that we haven't told them, like in the programming framework beforehand, haven't told them, but if they just learn to solve these tasks, so to speak, by themselves.
Interesting. And let me ask you a little bit of a different question. I actually tried to come up with a couple of questions with ChatGPT, but they all sucked. So maybe a different question is, you know, there are dozens of companies actually that are worth billions of dollars today. And a lot of people are getting very, very rich of the work that you and other academics have done. How do you feel about that?
I guess that's one of the, it's good for a laughter, right? That's a decision that you take when you're becoming a professor. Like, what's our job there? We're working at a public university. I guess we as societies have decided that we need this kind of work as enabler for a future of progress. That's why we're doing teaching, and that's also how we decided to develop Stable Diffusion as an open source project. My understanding was that this AI will in the future become ever more powerful. But when we released it in public, I saw this as a critical temporal window where what came out is not all to be taken for face value. There are still those glitches in there. And that meant, like, if you consider a future where the images become harder and harder, for instance, to delineate from reality, that was the critical time window where I thought we can inform society. How? Well, for the first time giving anybody the ability to just play out and see what it means to create content, in that case visual content, just by themselves. And with that, start thinking about the implications that had. And I had journalists contacting me saying, like, oh, now we cannot take images for reality, to which I can only answer, well, did you do that beforehand? I mean, if you just go to the internet, how could you actually consider all that is there to be like the truth or be true data? And that told me how important it is to democratize this technology and give average users a better understanding of actually what's going on, because that seems to be the best mitigation strategy that we have for what's going to come.
Yeah. When you think about AI research and you bucketize it into maybe the hardware, the software, the algorithm, and the data piece, what do you think is the biggest opportunity for actually improving the state of AI?
That's a very good question. And I guess it also, as an entrepreneur, depends on the assets that you have available. The easiest answer is we need everything. Yeah? Of course, we need better hardware. I find the progress that we've been seeing there in terms of GPU computing important, but it's definitely not on the level of the demand that we now already see happening. So this is important, but I guess not everybody here has a company like NVIDIA in their backyard to actually do that. Then there's like the foundational level of the software stack. Things like the big foundational models there, which, as we all know, require a lot of resources to put together. It's very important that this development continues there. There's European initiatives trying to actually open source that and make sure that as it is and will become a very critical technology for the future, that this will be openly accessible. I think this is a very important sort of objective. The Lion Initiative and others are going in that direction as well, but it requires sort of a large number of people coming together, large resources, and we need to think here also on European soil about supporting that more from a governmental level. And then comes what I try to outline in the talk: where would you have, as an entrepreneur, as a startup, most leverage? And I see this now with the application design powered by generative AI, where you have most leverage with limited resources that you have available, and where you can set yourself apart by means of the data, the potentially proprietary data of the customers that you're actually developing the software for.
Great. Maybe one last question for you. So everybody has been given their predictions of the future. What do you think are one or two things that will happen between now and if we sit back down here in a year from now?
Yeah. I'm excited to see generative AI change the way that we interact with computers. I'm a computer scientist by training, but isn't it frustrating a lot of the time telling a computer what it's supposed to do? You do it in Photoshop, do that pixel and so on. Having a natural interface to a machine that will enable so much more productivity, reduce frustration to a certain part, and make us, as users of this machine, so much more powerful there. And then you have also other things like people that are creative but lack certain gifts to actually turn that into pictures or whatever else, getting them back into the game. I guess this will in the future profoundly change, even more change our future than the personal computer has done in the past, because now it's not just you having this machine, but you're having a much more effective way to actually utilize this machine. And I guess it's hard to underestimate the enormous potential that this will have, and to see all the applications that this will actually create.
Great. Well, thank you so much for your talk and for answering all of our questions.
Absolutely, great to be here.